you can see a car accelerating toward the right. The car starts at 50 meters and accelerates at 4 meters per second per second. Let's do that again. Now, the car doesn't start at the origin. It actually starts here, right? Because that's when the stopwatch actually starts recording time. So the experiment doesn't really begin until it passes the 50-meter mark. So when the car passes 50 meters, that's when the stopwatch starts. And every second, the car is going faster, 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 and faster. And since it's going faster and faster and faster, it's covering a greater amount of distance from 1 second to the next. And of course, since we now have this data, we have velocity, time, position, we can make a table. And now with this table, we can build a graph. So let's look at velocity versus time. Now look at the velocity. Every second, it starts at 10 meters per second, and every second just goes up by 4. So it's a perfectly straight linear line. Now if we plug this into a spreadsheet, we would get an equation like this. Y equals 10 plus 4x. Now, the y-axis is velocity. Not just 10, but 10 meters per second. 4 meters per second, and the x-axis is time. So what we did was we just simply changed the y's and x's to v and t, and we included the units of the graph. We can also do the same thing with position. Now, but look at position. It starts at 50, but it doesn't go up in a linear way because the car is accelerating. It's going up a greater and greater position every second. Now, if we plug this into a spreadsheet, what would happen is we would get a quadratic equation, such as this. Y equals 50 plus 10x plus 2x squared. Now let's just replace our variables. It's not the y-axis, it's position. So let's call that x, not just 50, but 50 meters. 10 what? Well, 10 meters per second. The x-axis is time. And we have meters per second times t squared. Now, if you're wondering, like, how do we figure this out? You have to remember that right here, this is velocity. So that's meters per second, meters per second, meters per second. Like, all these terms ultimately work out to meters per second. Velocity is meters per second, that's meters per second, and this is acceleration. Acceleration times time, when you multiply them together, you get meters per second. So that's the velocity equation. The velocity equation is all in meters per second. The position equation is, well, all in meters, 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 and meters. Like, all this works out to meters. So for that to be true, this has to be meters. And this has to be, well, this has to be meters per second. This has to be meters per second. So ultimately, everything works out to meters. Now, look at these quantities. Obviously, we know v is velocity, right? This term right here is the initial velocity. This term right here is the acceleration. This term right here is the initial position, the initial velocity. And if you look at this, 4 meters per second, that's the acceleration, right? Because every second you're going up 4 meters per second faster and faster and faster. Now, since this has the same units, but this is half of 4, so even though it has units of acceleration, it doesn't represent the acceleration, it actually represents half the acceleration. So what this means is we can generate new equations from this. So we have this equation. So this equation, v equals v naught plus at, this is the generic equation from a velocity graph. So this is, we can find the velocity as a function of time. So we can find the velocity at any particular point in time. That's it. And this equation, this tells us the position of an object as a function of time. So we can find the position of an object at any time we want for an accelerating object. So these two equations here are the equations for accelerating objects. Now before, we didn't have this term before because we were just dealing in constant velocity. But since we are now dealing with acceleration, we have this 1/2 at squared term. Now, just to go one step further, just so we can understand this, is, of course, this point here, this is the initial velocity. The slope is the acceleration since it has units of meters per second. And this area here, this area here is the displacement since it has units of meters. Because if you multiply meters per second times seconds, you get meters. So this area is displacement, aka the change in position. Well, look at it this way. I like to look at these objects as, instead of like one odd gigantic shape, I like to look at it as just, basic shapes. Like this is a rectangle, this is a triangle. Let's say the object starts at an initial velocity v naught and it goes to a final velocity v in a time t. Well, you can look at this in areas. This area right here is v naught times t, right? It's just, the base times the height. Now this area right here, once you work out the mathematics, which we're going to do in class, this is 1/2 at squared. Take a look how this is just a rectangle. It's a simple velocity times time, but look at the 1/2 here. That 1/2 is there because this is a triangle, right? It's not a rectangle. That 1/2 is because we're taking half the area of a rectangle. So the total area is the displacement. So delta x, displacement, your change in position, you got to look at it this way. It's the area of the rectangle and the area of the triangle, right? So you just add them together. So v naught t is the area of the rectangle, right there. And this here is the area of the triangle. So if you add these areas together, you get the total displacement. So delta x equals v naught t plus 1/2 at squared. So we can find the change in position for an accelerating object. And it works whether the velocity is increasing or you start here and the velocity is decreasing. It's all about areas because in physics, like everything has a meaning, right? The y-intercept has a meaning. The slope has a meaning. Everything has a meaning. So these are the equations of motion, and we're going to be doing some interesting problems with them. Until next time, more physics is coming.